Here we have a graph of kinetic energy in joules versus velocity in meters per second. Now we know there's a clear connection between kinetic energy and velocity, but let's look at what the slope of this graph means. Well, we'll interpret the run and the rise and the slope between two graph points. Now if the points are 2, 7, that means that we have a run from 2 to 4. That's 2 meters per second to 4 meters per second. Okay, that's a run of 2 meters per second. And we have a rise. Let's zoom in a little bit here. Okay, we have a rise that goes from 7 joules to 28 joules. And that's a rise of 21 joules. So the slope, bring it down where we can see it, slope equals 21 joules over 2 meters per second, which is 10.5 joules per meter per second. Now we could reduce these units down to kilograms and meters and seconds, and that's what we ordinarily do with units, but right now we're trying to think in terms of interpretation. And if our slope is 10.5 joules per meter per second, what does that tell us? Well, that's the average slope of this graph, and in fact, if this is an object of constant mass, the graph of kinetic energy versus velocity is going to look like this. It's going to be a parabola because the kinetic energy is proportional to the square of the velocity, and the coefficient of v squared is going to be 1/2 m. So this is going to be a graph of 1/2 mv squared. And we could easily determine m from all that, but we're not going to do that. What we're really interested in is seeing how the kinetic energy changes with respect to the velocity. And what we're saying is now between 2 and 4 meters per second, the kinetic energy increases at a rate of 10.5 joules for every meter per second. Now if we took 2 more points on the graph at higher velocities, we would find that the graph gets steeper, because the graph does have this parabolic quality. So the number of additional joules you get for every meter per second increase in velocity is greater the greater your velocity is. So as velocity gets greater, kinetic energy goes up more and more steeply as velocity increases. The rate at which kinetic energy changes with respect to velocity will increase as the graph goes on. And this is the rate at which, the average rate at which kinetic energy increases between these two velocities. And that is just an average rate. We can't have a linear kinetic energy versus velocity curve for our linear graph for an object of constant mass. The graph has to be parabolic.